Hi guys, I am Ankit. In this video we shall see another problem on LeetCode. Toeplitz matrix. So given matrix of dimension m cross n, we have to return true if the matrix is Toeplitz. Otherwise we have to return false. So first of all, let's see what is Toeplitz matrix. So if every diagonal from top left to bottom right has the same elements. So a matrix is a Toeplitz matrix if it has same element in every diagonal from top left to bottom right. Top left means here, bottom right is here. So if we see what are the diagonals possible, so one diagonal is this one, this one, other, right? And other, yeah, these are what diagonals possible in the matrix from top left to bottom right. And if the elements in every diagonal is same, elements in a particular diagonal is same, then we can say it's a two-place matrix. In this 9, only one diagonal, okay? Only one element in the diagonal. So 5, 5, 1, 1, 1, 2, 2, 3, 3, 4. Yes, this is a two-place matrix. Let's say instead of 2 here, we had 3. Then 2, 3, 2, which is not equal, right? So in this case, it won't be a two-place matrix. So this is the question. So how do we solve the problem? What is the approach? So if you see, one we do is row-wise here, this row, this row, this row. So from this row, diagonally you move, second row diagonally move, third row diagonally move. Then column, this column, this column, this column, even this column also. Diagonally move, diagonally move, diagonally move. So what we'll do is we'll have to run check the elements diagonally from row wise and column wise. So once you start from this row, this. Next, you need to check for this column. First column need not because first row, first column will be pointing to same cell. So first column is not required. From the second column, you can start checking diagonal because for this column, already have checked the diagonal in the row itself. So how do we check it? So what we do is we run the loop. Let's do for row wise. Okay. Run the loop I equal to 0, I less than m, I plus plus. What we do is now we are in the first row, right? Let's say x equal to the row and y equal to 0 initially. Because in each row you start from 0th column, no? That is the reason. So x equal to the given row, y equal to 0. Because we are doing row wise. And we'll have a variable value, let that be equal to matrix of x comma y. That is nothing but this value. Let 1 be stored in the value so that we can compare this 1 with every other element in the diagram. Okay, so while x and y, x is initialized to row number, y is initialized to 0. Why 0? Because we are moving row wise. So that means we are starting from 0th column every time in the diagonal. And then a value, we store the value 1 in the given variable value. So next, what you do until x is less than m and y is less than n. M is row length, and y is n is column length. So what you do is check if value is not equal to the matrix of x comma y. 1 equal to 1 initially. Okay, if it is equal, x plus plus, y plus plus. Here also again this one is equal to the value 1, value is 1 initially. Okay, increment x plus plus, y plus plus, it will move here. So initially x is 0, y is 0, 0, 0, 1. Okay, I'll write this 0, 1, 2, 3, 0, 1. So initially what you have? 0, 0. Then x plus plus, y plus plus will move to 1, 1, this cell. Again, x plus plus, y plus plus, this cell. Yeah, 1 is equal to 1 is equal to 1. So yeah, that is okay. Here we have not got any contradictory one. So if in case, let's say instead of 1 here we had 5. So in this case, the value was 1 and the value which you got at this position is 5. Y is not equal to 1. In this case, you return false. If it is not equal. If it is equal, just put x plus plus, y plus plus until you have x less than 1 and y less than n. So once this is done, this row is done, move to next row. So next row what you do? So in this case, I will be 1. So x will be 1, y will be 0. So this cell will be pointing. Okay, this cell. Now value will be 5. And check x less than m, y less than m. Yes, it is true. Check this 5 is equal to 5. Yes, it is because starting it will be 1 comma 0. Next, x plus plus y plus plus. So x plus plus means 1 comma 0 would become 2 comma 1, which will be pointing at this cell 2 comma 1. So is y equal to the value 5? Yes, it is. X plus plus y plus which is out of mode. That will be 3 comma 2, which is not present. Similarly, you do for third row also. Now same thing you have to do. Once you're done with row, check for column wise. So, but column you need not to start from 0. You can start from 1. Why? Because the zeroth column is nothing but zeroth row itself. The diagonal is same. So you start from first column till less than n. Okay. And in this case, x and y, it will be shuffled. I mean interchanged. So x will be nothing but row. So you will be starting from zeroth row always, and y will be nothing but the given height column. Got it? Because whenever you start with a diagonal, first row, first row, first row. That's why row will be initially 0, y will be equal to the column number. This. And same thing. Store the value x plus plus y plus plus. If it is not equal, return false. If it is equal, x plus plus y plus. After the entire running this condition for the entire matrix, if you don't get this condition, then you return true. If in between this condition becomes true, then you return false. That means if in anywhere you find a diagonal element not equal, then you return false. So this is how we check whether the matrix is Toeplitz matrix or not. So quickly we shall implement the logic. So n be the column size. I'll take one of the rows and find the column size. Next, what should be done? So we'll run the loop. It should be m, right? Column wise you are moving. So here in x equal to I and y be equal to 0. And then initialize value. That will be nothing but matrix of x comma y. So next we have to check while x should be less than m and y should be less than n. What we need to check each time whether value is not equal to matrix. So if in case you find the given value is not equal to matrix of x comma y, then you return false. Otherwise, x should be incremented, y should also be incremented because you're moving diagonal. Now this is row wise. Same thing we have to implement for column wise. I will copy paste the code. I will be 0, I less than n. We'll start from I equal to 1. 0 is not required. If you start also, it's not a problem. So in this case, x will be 0 and y shall be I. Everything else remain the same. So as I said, if after the entire matrix is iterated and you still don't get this condition anywhere become, becoming true, then that means it's a Toeplitz matrix, so you return true. So we shall run this. Yeah. And for Java also same logic applies, nothing change you have. We can submit and check. Yes, successfully submitted. If you understood the concept, please do like the video, subscribe to the channel. We'll come up with another video next session. Until then, keep learning. Thank you.